Welcome back, students. This next part is explaining what are the conditions necessary for equilibrium to occur. First of all, the reaction has to be reversible. It has to have a backwards arrow. If you burn a piece of wood, you can't get it back. It's not reversible, can't be equilibrium. Number two, has to be a constant temperature. If you change the temperature, you change the dynamics, and lots of other things change. So it's got to be constant temperature. It's got to be a closed system. We can't have reactants leaking out. Okay? Reactants and products both have to be present. Until the products are there, you can't have a backwards reaction. And finally, you need a constant macroscopic property needed to identify if equilibrium has been reached. So that means macroscopic is large, detectable, observable. So iodine is purple. So if hydrogen were colorless and iodine's purple and HI is colorless, before this reaction started having collisions, like the second before a collision happened, H2 crashed into I2, I'd have iodine in full concentration, so I'd have a purple color in there. But as the concentration begins to decrease, because reactants are forming products and the concentration of iodine's dropping, it would get less and less purple, right? I'd have purple turning into colorless, so it would become light pink. So I could see that happen, and I could reasonably detect the color change because of that macroscopic property. Okay, and those are the 5 conditions necessary for equilibrium. The next lesson talks about the equilibrium law expression and the equilibrium constant.